In this video, I'm going to cover concepts from chapter 1. I'll be following the PowerPoint notes. You may download the PowerPoint notes and take a look at that as you listen to this video, as you watch this video. And I'm not going to be covering each and every slide from the PowerPoint notes. I'll be covering only the concepts, important concepts that are covered in the slides. Now let's start with the term statistics. Statistics has two different meanings. Okay. One is the statistics that we compute from a sample. That's also called statistic. Like you take a sample and compute the sample average, and the sample average is called a statistic about that sample. A median, you compute median for the sample, or some percentiles or variance or standard deviation. All of these are different statistics that we compute from the sample. And the second meaning for the word statistics is the field of statistics, the art and science of collecting data, analyzing data, and making interpretations about the population from which the data is taken. So the field of study is also called statistics. So there are two different meanings to the word statistics. Now, data and data sets. Data is about a value that we data are the facts and figures that we collect and summarize in a presentation. So, and a data set is a collection of data. An entire study will have a data set. Now, there are four major concepts about data. Okay, there is elements, and there are variables, there are observations, and then there is the data set itself. Okay, let's look at an example of that. So here we have the stock market information about different companies. Okay, and we're going to collect data about which stock exchange the stock is listed, what is the annual sales, and what is the earnings per share. So here the companies are the elements, because the companies are the ones from which we make the observation. Now, the values that we collect, they are the variables: stock exchange where it is listed, annual sales, and earnings per share. So these are variables. An entire row of data is called an observation. So an observation is an entire data set, entire data for a given element. And then all the rows of observations, a collection of all the observations, is called the data set. Now, the variables that we collect data for, and they can be classified into four different scales of measurement, the way in which we measure the values. So nominal, ordinal, interval, and ratio. Nominal and ordinal are what are called categorical variables, and interval and ratio are called quantitative or numerical variables. And let's look at the properties of these four different measurements, scales of measurement. Nominal is where the observation is categorized into a given group, a particular group. So these are labels, and that identify which group the observation belongs to. An example would be like students in the university are classified into what majors they belong to: business major, humanities, education. Now, these categories can be labels like management, business, humanities, or it could be numerical code assigned to those categories. 1, 2, 3, and so on. So just because it appears as a number doesn't mean these are numerical variables. Those number codes still only represent the categories to which the observation belongs. So to that extent, even though it has a numerical appearance, it is still a categorical variable. And these are nominal because there are no higher and lower hierarchical relationship among these categories. So business is not greater or smaller or equal to humanities. So these are simply categories that assign different observations to different groups, and there are no hierarchy among those groups. If you have hierarchies among those groups, then it is no longer nominal. That scale of measurement is called ordinal. Ordinal is there is a rank among those categories. Like for example, freshman, sophomore, junior, and senior. So these are categories, but there is a ranking here, inherent ranking. So that's what makes this categorical scale an ordinal and not a nominal scale. So if there is ranking among the values, then it becomes an ordinal and still can have a non-numerical label, or it can have a numeric code which may still refer to only those categories, and the number itself doesn't have any numerical significance. So now the other two, interval and ratio measurements, and there's a very key difference here. They both have meaning. The numerical value has significance. Okay? So it's no longer just labels, and there are numerical values associated with the variable. Okay? And the critical difference between interval and ratio is whether the zero value has a meaningful significance. Okay? For example, if you're talking about amount of cash you have in the bank, okay, then zero has a meaning. So it doesn't change from, or it cannot be misunderstood, it cannot be understood differently by different people. So, and if you have overdraft protection and you've overdrawn, so it can have negative balance, you can have zero balance, you can have positive balance, and that makes it a ratio scale. Okay. What makes an interval scale is when the zero is arbitrary. For example, you take the temperature measurement. Okay. If you use Fahrenheit measurement, then the zero value represents a particular level of temperature. That zero may be understood differently if you use Celsius measurement. In Celsius measurement, it will be different. So Celsius zero is 32 Fahrenheit. Okay. They both represent the same thing, but the values have different meaning or different significance. Okay. Another way of looking at interval and ratio is if you double the amount, then the significance or meaning also doubles in a ratio scale. So let's take the interval scale of temperature. So if you have 50 degrees Fahrenheit, then you double it to 100 degrees Fahrenheit. So 100 degrees Fahrenheit doesn't mean it is twice as hot as 50 degrees. We know that it is hotter, but it is not twice as hot. It is just a measurement scale that doesn't mean that it is twice. Whereas if you take $50 and then you have $100, then you say $100 is twice as much as $50 very clearly. And therefore that would be ratio. Okay, interval versus ratio. In interval, there is no inherent zero, universally understandable zero, and also when you double the whatever the concept that is being measured is really not getting doubled.